All right, so we're recording now. These are called the product to sum and sum to product formulas. Why would you ever want to know these things? We don't know. So these come out of the formulas. They're developed out of the sine of the double angle and the half angle formulas. And so what they are as ways, are ways to convert products to sums and sums to products on the second side, okay? Sums to products. And why would you ever want to do that? Because in calculus, a lot of times, and I was told this by Mrs. Hine, because when I taught AP, we didn't really have to break these things down like that, but when you take, if you do take calculus BC, and even some AP classes, this is useful for when you do integrals. So that's why you want to do it. And the other one is kind of useful for solving trig equations. So we're going to just, these formulas, by the way, I would give you on the test, okay, because they're really hard to memorize. I still have to look at them all the time. So I would, whoops, wrong tool. I want to get this thing. So I'm just going to copy these formulas over here and put them somewhere. Where'd they go? And then I'm going to go back and I'm going to grab this now, and they'll say find the exact value of this. Whoops, I didn't want to put it in a new page. I can do edit file, edit, copy, and then if I go back, and I could go here, and I could go, where's that? There it is. Okay, so looking at these formulas over here, all I'm really doing in these is plugging into formulas, okay? So sine 6 theta plus sine 4 theta, which one does this look like? Formula 1, 2, or 3? It looks like formula 1, okay? So what I do is I just plug in 6 theta in for A and 4 theta in for B. So when I do this, what I get is, hard to see from this angle, what I get is 1/2 of, and don't forget big parentheses first, cosine of, this is alpha and this is beta, okay? And so that's 6 theta plus 4 theta, and that itself is in parentheses. And a lot of times on the tests, people think this is 60 degrees. It's not. It's 6 theta plus 4 theta minus, minus, thank you. See? Minus, and over here I have minus cosine of alpha plus beta. So I get 6 theta plus 4 theta, and then I just simplify that. Whoops, go away. I make this go away. 4 theta, and I close that parenthesis, and then I just simplify a little bit. 1/2 in parentheses cosine of 6 minus 4 is 2 theta minus cosine of 6 plus 4 is 10 theta, and then I'm done. That's it. That's all there is to it. No, you don't even plug that in. Okay? So they might ask you what's like the cosine of 60 times the cosine of 40. Then you can plug that in, right? But in this case,
would you not say that it's
what?
Would you not say that it's half cosine?
Negative 8. No, you cannot. You can't put these together, right? You can't say cosine of 2 theta minus cosine of 10 theta, right? That's not equal to cosine of negative 8 theta, right? Not true. No, you can't even, yeah, I guess you could multiply through the 1/2, but, well, 4. Right? Yeah, well, there's, I mean, it'll just make it more complicated. Okay, so let's do this one because it's slightly more exciting than the next one. Let's do the next one. So, not that one. I want to do this one because it's somewhat more interesting, but not much more interesting. I'm not going to put it in a new page. I'm going to put it in the same page. Okay, so if I grab this one, where'd it go? There it is. Okay, so I'm going to do this one, and this formula looks kind of like this, right? So plugging in, I'm going to get that is equal to 1/2 sine of A plus B. So that'd be 1/2 sine of what's 3 theta plus 5 theta? 8 theta. Okay, so I'm kind of skipping a step here. Plus sine of 3 theta minus 5 theta, which is negative 2 theta. And the part that's a little bit more complicated here is that, I guess I should put a parentheses there too, is that sine of negative 2 theta can be written as negative sine of positive 2 theta, because sine is an odd function, okay? So I could rewrite this as 1/2 sine of 8 theta minus sine of 2 theta, okay? And don't forget that this parentheses has to be around the whole thing. All right? Is that hard? Easy, right? Just plug it into a formula. All right. Now I'm going to go on to the next page and talk about some of those. I'm skipping the other one, I guess. So in this case, you're going the opposite direction. You're taking a sum and you're turning it into a product. So if I want to do this one, A, I just plug into this formula, and so I would get 2 sine of 5 theta. Wait, that's the wrong formula. I want to use this formula, right? Sine of alpha minus sine of beta, which is this one. So I'm going to get 2 sine of A minus B, which is 2 theta over 2 times, right, cosine of alpha plus beta, which is just 8 theta over 2, which is 2 sine theta cosine 4 theta. And that's your final answer. That easy, isn't it? Isn't that easy? Should we do one more? Sure. No more, please. Okay, so this one here, let's do that one there. Okay? So I have to look at the formulas. So for this one, I'm not going to place capture in the new page. I'm just going to capture it. Let's just do this one, and then where did it go? Oh, it's up here. Okay. So if I want to do this one, cosine 3 theta plus cosine 2 theta, I'm going to use this formula, right? So it's going to be 2 cosine of 5 theta A plus B divided by 2 times cosine of A minus B, 3 minus 2, which is theta over 2. And then I think we're done, aren't we? Whoops. Cosine 2, I'm using this formula right here, right? So it's 2 cosine times cosine, so cosine A plus B over 2 cosine A minus B. And then you're done. Done? Okay, I want to do one more, which you might run into, which is an identity problem. Okay? And I know how you like identities, right? Right, Logan? Okay. So say you have an identity. This one's not on your sheet, but you have a couple like this on homework. So show that, and when they say show, that's kind of an identity. Cosine theta plus cosine of 3 theta, over 2 cosine theta, 2 cosine 2 theta is equal to cosine of theta. And you say, I don't know how to do that. Say that. Okay, very good. So then you go back to your sheet and you grab, I'm going to grab these formulas here so that I can do that. So I'm going to look at these formulas. Okay? And look at how nice that works. What did this say? Oh, I can move this down here so you can see what the problem is. Okay, so probably what I want to do is use this formula right here. See that formula? Because here I have a cosine A plus a cosine B. And I plug the numbers into this formula. And hopefully things will disappear. So when I rewrite this, I have 2 cosine A plus B, which is what? What's theta plus 3 theta? 4 theta divided by 2, right? Times cosine of theta minus 2 theta, right? Minus 2 theta divided by 2. And that's equal to and it's still all over this, right? Over 2 cosine 2 theta. And so now when I rewrite, I get 2 cosine 2 theta, because that's 4 theta divided by 2, times cosine of negative theta, because that's negative 2 theta divided by 2. What? Yeah, we're getting there, right? And on the bottom I have 2 cosine 2 theta. 2 cosine 2 theta. And what could I cancel out? Yes, I could cancel out this. Okay? The 2 cosines 2 theta. A lot of you guys want to, if this is a plus sign, you can't cross things out. And a lot of you guys on your test, I see you doing stuff that is equivalent to this. You go 3 plus 5 divided by 5. That's equal to 3, right? Okay? That's what you do. Don't laugh. Especially if it's got sines and cosines. Because you get confused and you say, oh, I can just, if this is a plus side, I could just go like that. Because this is what I saw. I saw cosine squared x plus 1 over cosine of x or something. And you go, oh, I could just make one of those cosines. You can't do that. Okay, that's exactly what you would have done here. Okay, so don't do that. You can only cancel things if they're being multiplied together, if everything's being times. So this is equal to cosine of negative theta, which Logan said that since cosine of a negative angle, since cosine is even, this is one of your identities, that's equal to cosine of positive theta, right? And so now you have shown that where you were trying to get to is there, and you're done. And you write QED here, which means in Greek, I don't know, it means what you set out to do is done, something like that, okay? And your homework is on the bottom of the sheet, and remember, you heard it here on roller derby. Roller derby, where did that come from? Okay. Stop.